Okay, I had a question on some of the homework problems. Some of the end ones are getting pretty difficult. So I'm on page 387. I'm going to do number 24, which is very similar to number 23. And then hopefully you can do 23 by yourself. So the question is, find the 6 trig functions of theta given these two clues. Tangent of theta is undefined and theta is between pi and 2 pi. So I have a rectangular grid here, but I'm going to identify the axes as if I have a circle. So this is going to be 0 degrees here. This is going to be pi over 2, pi, 3 pi over 2, and then this would also be 2 pi. So it could be 0 or 2 pi, depending on the angle we're thinking of. So we need some angle that's between pi and 2 pi. So it's either going to be in the third or the fourth quadrant. Right? So either here or here. And the tangent is undefined. Well, the tangent of any theta is opposite over adjacent. So for tangent to be undefined, I need the adjacent side to be 0. So let's just take a random angle in this quadrant for a minute to think about it. If this is our theta, let's use the hypotenuse as 1, so we're sort of working off what's called the unit circle. So if I take this particular theta, I can count 1, 2, 3, 4, 5, 6, 7. This side is 7, and this side is 4. So in this picture, the tangent is opposite over adjacent, or the tangent of theta is 4 over 7. Well, I need the bottom to be 0. So let's look at another triangle in this quadrant. Suppose I take and I draw this right triangle here. So I have a bigger theta, right? So let me get that other one out of the way a little bit, okay? And so again, I'm going to use the hypotenuse as 1, right? This side here is now 4. This side here, 1, 2, 3, 4, 5, is 5. So now I have the tangent 4 over 5. Whoops, wait a minute. Tangent is 5 over 4, opposite over adjacent, 5 over 4. Now remember, I'm trying to get the bottom 0. All right, let's just take one more. Let's suppose I use that side, right, as my right triangle. Very tiny. Over 1 unit, down 1, 2, 3, 4, 5, 6. So the opposite is 6 and the adjacent is 1. And you see, each time I make a triangle, as the angle gets bigger, right? I started with a small angle. As the angle is getting bigger and then I draw my right triangle, the opposite side is getting bigger and the adjacent side is getting smaller. So what happens when the opposite side, or this angle, right, is so big that the opposite side comes out to be 1, right? So in other words, I'm basically at the 90-degree mark here. Well, if the opposite side comes out to be 1, right, think of this side becoming the same length as the hypotenuse. Well, that side becomes the hypotenuse. So I really have what I like to call the right triangle that has the opposite side 1 and the hypotenuse 1, which means this side would have to be 0. Even though I have that drawn as a right triangle, it's not a right triangle in reality, because if I have this side 0, it ceases to be a triangle because this line becomes right on top of this line. But the picture of that, in terms of doing the 6 trig functions, if I want opposite over adjacent because I want undefined 0, right, the opposite becomes 1. So for purpose of doing the 6 trig functions, I'm going to use that non-triangle there. And now if I take that as, this is my theta in here, so theta is right there. If I take the sine of theta, the cosine of theta, the tangent of theta, and then we want cosecant theta, secant theta, cotangent theta. And what are those values in terms of fractions? Well, the sign is opposite over hypotenuse. 1 over 1. Oh dear, I forgot something. What quadrant are we in? Third quadrant. Over 0, down 1. Is that a positive 1 or a negative 1? Ooh, negative 1. All right, so the sign is negative 1 over 1, which is negative 1. Cosecant is the opposite of that, still negative 1. Not the opposite, but the reciprocal. Excuse my use of terms there. Okay, cosine of this is adjacent over hypotenuse, 0 over 1, which is 0. What's the reciprocal of 0 over 1? 1 over 0, undefined, right? Okay, tangent, opposite over adjacent, negative 1 over 0. What's that? Undefined. What's the reciprocal of undefined? 0 over negative 1, which is 0. So, there are the 6 trig functions of that. Basically, whenever you get an angle that ends up on the axes, it becomes one of these special non-triangles. The difficulty is figuring out which of the two sides, the adjacent or the opposite, is 0. I do that by doing a couple angles in that quadrant as I approach either the pi or the pi over 2 or whatever I need to approach in that figure. We were looking for tangent undefined, so we knew that we had to have a 0 on the bottom of this fraction. So we knew we had to get an equation of a triangle that looked like that, or a picture of a triangle that looked like that, and that's where my non-triangle picture comes in. So good luck on 23. I'd like to do another example now. Okay, so for this next one, I have the line y equals 1/3 x, and I have quadrant 3 as the clue. And again, I'm supposed to find the values of the 6 trig functions. Well, I need to graph that line. I like to use the y equals mx plus b method, so y equals 1/3 x plus 0. So the y-intercept is 0, and the slope is 1 over 3. So that means rise over run, up 1 over 3. Down 1 over 3, and I can continue that a number of times if I want to get my line. Now, the question said the third quadrant, so I want the line in the third quadrant. So this is quadrant 3 down here. You should know that. So what did I say? A run of 3, a rise of 1. So here's our little triangle. This is negative 3. This is negative 1. I need to find that missing side. Use Pythagorean theorem. It comes out to root 10. You can do that part yourself, hopefully. Now, let's do the 6 trig functions. So, sine of theta, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta. So, the sine of that particular theta, opposite over hypotenuse, negative 1 over root 10, and then this one is going to be negative root 10 over 1. The answer book's going to call this negative root 10 over 10, so they like you to rationalize the denominator. All right, the cosine of this is adjacent over hypotenuse, negative 3 over root 10, and then this becomes root 10 over negative 3. The tangent, opposite over adjacent, so negative over negative becomes positive 1/3, cotangent positive 3. There you go with 26. I'm also going to do 28, so let's make this really quick. 28, it's very similar. On 28, you have the equation 4x plus 3y equals 0. Solve it for y, and you get y equals negative 4/3 x. I do plus 0, so all right, now, the other clue about this was it was in quadrant 4, so I have to remember that when I sketch this, I have to sketch it in quadrant 4. So I have to be careful. I know that the slope is -4/3 or 4/-3. And I want to end up in the 4th quadrant. So if I go rise of 4/3, I end up in that quadrant, or I can do a rise of -4 and over 3, and I end up down here, and I want the part that's in quadrant 4. You see that? So be careful when you're sketching. Or do you sketch, but then you could have done this sketch, but then extended the line into the other quadrant. Now I can do the 6 trig functions, sine, cosine, tangent of theta. We'll just do the first 3, and you can do the reciprocals yourself. So, what are the sides? Oh, always do your right triangle to the x-axis. I almost did it the other way around. All right, there's my right triangle. Here's my theta. So, this is a +3 and a -4, right? And what's the hypotenuse? I hope you know that's a special triangle, so it's 5, but of course you can use Pythagorean theorem to check my work. All right, so the sine of this theta, opposite over hypotenuse, -4/5. And the cosecant will be its reciprocal. All right, the cosine of theta, adjacent over hypotenuse, 3/5. Tangent of theta, opposite over adjacent, -4/3. And there are 3 of the 6 trig functions. You can do the rest. Good luck with this assignment.